All right, we're on. I wanted to put my mug up here in the corner real quick. Uh, so anyway, I've tried to work this problem for you about twice. All right, we're going to look at problem 10 on the on your homework on your chapter 26 homework. There's just some interesting things there. Would this be a question that's like on the final? No, more it's more like question 9. All right, but I'm going to get them. I'm going to set them up because I'm having algebra issues today. It's mainly what you have to use is you have to use electron volts and some of the things that we use in modern physics problems. And I don't think we covered it. I picked the problem because I thought, oh, it'd be kind of a straightforward type thing. Not the case. All right. So let's just go ahead real quickly. And let's take a look at the problem. Here it is. It says an electron has a speed of point. So let me get that written down. That's the only thing that they give us, 0.860 C. And we're going to carry this out to at least 4 to 5 sig figs in our calculations. And we have to be careful. That's what we have to be careful with. All right. But I'm going to write down 2 other. So that's all we need to know for right now. All right, so for working problem 10, okay, what they're saying is if the electron is going, if this is the velocity of the electron, okay, and the rest energy of the electron is 0.511 mega electron volts, you must work in electron volts, otherwise you will go, your calculator will explode. This is of the electron, and the rest energy of the proton is equal to 938 mega electron volts. Okay, we want to figure out if the rest energy of the proton, what its speed is when it is equal to the kinetic energy of the proton, what its speed is equal to compared to the kinetic, if it is the same as the kinetic energy of the electron. All right. All right. Well, first of all, we know that the total energy of a system is equal to the rest energy plus the kinetic energy. So the kinetic energy is equal to E total minus E naught. And we know that E total, and this is then is equal to gamma times E naught minus E naught. So we just set it up this way. We go, oh, well, let's factor out the E naughts here, and we got gamma times, oh, gosh, factor, we got gamma minus 1 times E naught, okay? And that is going to equal the kinetic energy of the proton, all right? Now this is the kinetic, this is the gamma function of the electron, all right? Okay, and we can just compute that pretty quickly, but let's set up the algebra first. Oh, but so then this would be the gamma of the proton minus 1 times the rest energy of the proton, right? So I've got a number for that. So I'll say, well, gamma p minus 1 is equal to gamma e, which you can figure out, minus 1, times echo naught of the electron divided by the echo naught of the proton. Oh my goodness. Okay, so gamma p is equal to, I got to keep my electrons, my gamma e to the electron, which you can just get the number, minus 1 over echo naught of the electron, which we have a number, over echo naught of the proton, which we have a number. And then what you do is you say, okay, this is all just a number. Okay, that's all just, this is equal a number. We've got a number now. And the only thing we're missing is that gamma p of the proton, let's gamma p of the proton here is equal to this. Oh, but gamma of the proton is equal to 1 over the square root of 1 minus the velocity of the proton divided by c squared. Okay, so now look what we've got. All we got to do is you got to be able to tease this guy out of here. And that becomes kind of a little bit of an algebra trick. Let's go ahead and multiply both sides by this, okay, and divide by this. Wait a minute, that will get me no more. See, this is where I was having an issue. So this is equal to our block of numbers. Okay? Well, I can't work with that at all. So I'm just going to keep this block of whatever number we've got there. I'm just going to keep that. All right. So would this be like a test question? No, not at all. So so I've got. So let me write this out. We got 1 over the square root of 1 minus the beta. I'm just going to say the beta of the proton squared. Okay, we know that beta, the beta function that I like because that's what we used in is equal to VP over C. Okay, and that's equal to that number. All right. So now I'm going to take 1 over that number, take the inverse of that number, and say that is equal to the square root of 1 minus beta squared of the proton. Square both sides. 1 over this number squared is equal to 1 minus beta p good. And beta p then is equal to 1 minus, because we're just, or I can subtract 1 from it and multiply. All right, I'm going to bring this over here, minus 1 over that number squared. All right, that's what, and we know then that the velocity of the proton is equal to 1 minus 1 over that number squared. This is how physics. I mean, you're getting into how physicists work. Okay, this is part of this. That's why modern physics is so cool. You're finally getting into, oh, okay, so I've got to carry this math through that works, and it's pretty intricate math, as you can see. All right, it's pretty crazy. Okay, so there's how you do part A. I'm going to do another movie on how you do part B. Okay, all right.